Hi, just wanted to do a video to show you about this lab. Okay, got my goggles on and it's called the Drip Drop Lab, acid-base chemistry. We're going to use HCl and we're going to use NaOH, and HCl is an acid and NaOH is a base. And we're going to be looking at the balanced equation of them. And so you can write them right here. We're going to use a 1 mole per liter of each, and we're going to add in 10 drops of acid. Then we're going to add in 1 drop at a time with the base, and we're going to use a color indicator called phenolphthalein, and it's clear when it's an acid and it's pink when it's a base. And when you add in so many drops of acid, then it's going to be clear, and then we gradually add in a drop at a time of NaOH until they're equal. And when they go 1 drop over, then it's going to make it turn pink. So when it turns pink, it means it's totally reacted. Okay, so we're talking about the amounts, not just doing a reaction, but we're looking at the amounts. So we're going to do this reaction first. I'm going to probably videotape these 4 trials, and then I'll do the H2SO4, tomorrow after school at another time, because I think I'm going to run out of time doing all the reactions today. But I want you to go ahead, stop the video, and realize you're going to do HCl, and you have NaOH, and you have 1 of each because of the way it's balanced. You're going to have 1 of everybody because there's 1 ion at H and there's 1 ion OH, and that's what makes the neutral water. You're going to do the same thing again, but you have to double the NaOH with the next one because it's double the H's. It's H2SO4. So go ahead and draw the visual particle drawing so you know there's 1 of these for every 2 of these to make 1 sodium sulfate and 2 waters. It's really the H's and the OH's come together to form water, and you really can't see that. So we use this indicator to show that when you have equal amounts, it's still clear. But when you go 1 drop over, when you don't need any more, it makes it turn pink. Makes this indicator turn pink. It's called phenolphthalein. Okay. So let's go ahead and do the results. I'm trying to actually record them myself because I have numbers from the classes today. I want to see how mine come out. Okay, so I'm going to go ahead and put in 10 drops, and it's real important that you make the drops equal. So we're going to do 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to do another trial, so I'm going to do another 10. 1, 2, 3, 4, 5, 6. And we want to make the drops the same. So it's real important that you don't have any extra drops. So I did 6, 7, 8, 9, 10. Okay. And then we're going to do the other experiment, and we're going to try and do 20. I'm hoping I can get both done here. So I'm going to do 20 just because I'm going to run this next reaction with 20 drops. So I'm going to put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to do another pipette full and do another. So I'm doing 20 here. So that was 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it's really important, like you see here, trying to put equal drops. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we put in, so 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, hoping that all my drops are good. Okay. Then we're going to put an indicator, and it says 2 drops, but I think only 1 is necessary just because I don't want to waste it and I don't want to make it too crazy. So I put 1 drop of the indicator in each. And as you can see, they're clear because I added in the acid first. Okay. So we're going to do drops of NaOH, and the whole premise is that we're hoping that the concentrations, the amounts of chemical is good in terms of having the right amounts of base to acid in each drop. So that's hoping happens. So we put a drop in, it's 1. See how it turned a little pink, but we can stir it, and you don't want to lose drops as you stir. So 2, 3, 4, 5. I'm going to do 5 and just stop there. And you can tell it goes clear. And then we're going to do 6, goes clear, 7, it goes clear, 8, 9, and then we have 10. And then it actually goes and it's not done. See how it's not done? It's back to clear. So this is 11. And it still goes clear. I need to get more of the NeOH. And then that was 11. Then we have 12. Almost staying, but not quite staying. And then that's 13. So 13, it still doesn't stay. 14, and it's staying. So 14 is the first one, 14. So I should write down 14, but I forgot my pencil. So we have 14 for this one. We'll go ahead and do the next result here. So we have to make sure we have plenty of drops in our dropper before we start. So we have 1. I'm going to use a different toothpick. So here we're going to put in 1 drop of NeOH. So I'm putting in the NeOH now to see how many we need. So I had 14 in this first one. We're going to do 2, 3, 4, 5, 6, 7, 8. I'm going to stop at 8 and then just stir it up, and we're going to see it go to clear. Then 9, 10, and then we're going to go 11. Need to put more in here. And then we have 12, 13, and it looks like 13, but not quite. We're going to do 14. Looks like it has to be 14. It could be that my NeOH is not strong enough. I had it older. I didn't make new stuff, so it could be my solutions aren't perfect. But if we double the amount of the acid, we should have even more drops of NeOH. So let's try that here. I'm going to go ahead and put in 10 each. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it definitely is turning pink, but it's not staying pink. And then 11, 12, has to be consistent drops. So I'm going to go ahead and get more in my dropper. And then we have 13, 14, 15, 16, 17, 18, 19, 20. And it still doesn't go all the way pink. Then we do 21, 22, I think it was 20, 23, 24, 25, 26, it's getting close, 27, 28, almost 29. Oop, I think I went 30. I think that went to 30 by accident, but should have been 29. Let's go ahead and put in the drops for the next one. So we had 14 and 14, and this is 29. It might have been 30 because I had an extra drop, I think, in there, but go ahead. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 in there. And then we have 13. I'm going to go ahead and stir it. 13, 14, 15, 16, 17, 18, 19, 20. Still not staying. See how close I get to the 28 or 29. So 20. Here's 21, 22, 23. Ooh, staying. 23, 24, 25. Oop, it's staying. I had 24, didn't I? I definitely think that was it, 24. Okay, so let me write down my numbers. I didn't get a chance to grab a pencil, but let me write my numbers down real quick so you can see it in the video. Okay, so I grabbed the pencil. So here we had 14 drops. Here we had 14. Here we had 29, and here we had 24. I think it might have been 25, something like that, 24 to 25. I'm not sure. I might have to go back on the video and correct it. I think it's 24. Okay. So this is telling you it should be close to 1-to-1, but it could be that my solutions were off, that these weren't exactly the right concentrations of a moles per liter. So, but hoping that they were the same. It definitely got higher, almost doubled, which is a good thing, because having twice as much acid, you should have twice as much base. Okay. And we'll run through the next experiment on another video tomorrow. Okay. I'm going to save that and share it with you absent students.